Hi everyone, welcome to your first lesson of mathematics in year 11. Just to make you aware, we're going to go through quite a bit of graphing work in this first term. It's really important because it's not something you were able to do at home, so we removed it from the syllabus whilst you were working at home, and obviously we now need to cover it now that we're back, okay? It is something where you need a lot of teacher input, and we didn't want you to feel like you didn't have that support fully because you weren't in lessons, okay? Before we actually move into the graphing units, what we need you to do first is make sure that you understand the background information. So we are going to look at some fluency questions that relate to parts of the graph work that we are going to be doing. Okay, so first what I'd like you to do is press pause and try question 1 here, and then press play when you're ready to go through the answer. Okay, well done. Let's take a look at question 1a first, okay? It's asking you to put these values into this function machine, and what that means is you put the input, which in this case would be a positive 2, okay, and then you would multiply it by 2, and then you would add 3, and then that would give you the output value. Okay, so let's do that. We have a positive 2. We are going to first multiply by 2. We are then going to add 3, and that will give us our output. Okay, so let's take a look. Positive 2 times 2 we know is 4, and a 4 plus a 3 is 7, so our final answer is 7. Okay, well done if you got that. Part 2. Okay, we are putting in a negative 4, same function machine, so let's just copy that out. And that gives us our output. So negative 4 times a 2, well, a negative times a positive, okay, is a negative still, so that would be negative 8. And then negative 8 add 3, we are getting more positive, so less negative. So that means we're going to have negative 5 as our final answer. Okay. Part B is asking us for the actual function that is in each machine. Okay, so for the first bit, we're going from 2 to 5, 4 to 7, and then 6 to 9. Okay, we have to look at what's the same about each input becoming the output. What are we actually doing? What's the operation? Well, 2 plus 3 is 5, 4 plus 3 is 7, and 6 plus 3 is 9. Okay, so that's fairly straightforward that for this one, we are adding 3. Okay, let's look at the next one. We have 2 moving to 6, we have 4 becoming 12, and we have 6 becoming 18. Okay, so we have to think about different operations. Yes, this one was adding. We might have subtracting, but this isn't going down, so that wouldn't make sense. But we could also have multiplication and division, okay? And in this case, we look 2 is becoming 6. Well, that would be plus 4. 4 is becoming 12. That's a much bigger jump. That's plus 8. So I'm now thinking it's not addition. It's likely multiplication. So let's take a look. Well, 2 times 3 is 6. 4 times 3 is 12. And 6 times 3 is 18. Okay, so we know for this one that we are multiplying by 3. So that would be our answer, to multiply by 3. Okay, so well done on that question. Let's take a look at the next one. Okay, right, so this is a fluency question in terms of measures. In this case, it's time. It's also about reading a scale. Okay, I would like you to do that. Pause the video, have a go, write down your answers, and then press play when you're ready to go through that. Okay, well done. Let's take a look at question 2 now. I think you really have to pay attention to where we are in terms of our increments, okay? So this is 10 a.m. and this is 12 p.m. That's a difference of 2 hours. And then 12 p.m. to 2 p.m. is another difference of 2 hours. And you'll see that there are 4 squares, okay? Well, that means that halfway must be 1 hour. And that halfway, again, must be half an hour. So each little square is half an hour, okay? And that should help you as you do the question. So if we look at A, well, part A is sitting on 10 a.m. So we can confidently say that that is 10 a.m. If we look at part B, that's halfway between 10 a.m. and 12 p.m., which we know is 11 a.m. If we look at part C, then that is only one small square. Now we've already worked out by looking at it that that's half an hour. So we can confidently say that that is 12:30 p.m. Okay. And now that's interesting. It's halfway of a halfway of a halfway. Okay. So in other words, that leftover bit is 1/8. So let's take a look. So we would have at this stage, and I'll just use the arrow to help us, we would have 1 p.m. At this stage, we have 1:30 p.m., and this is half of half an hour, which we know is 15 minutes, so we can say 1:45 p.m. Okay? So it's really useful to recognize that 15 minutes is half of half an hour when you're on a scale. I know that you know that that's a quarter of an hour, but you need to think of that as being half of half an hour because it does help you when you have a scale like this. Okay, so well done on that question, guys. Let's move to the next one. Okay, I'm going to make this full screen for you to pause because it is a little bit harder to see when it's half a screen. Okay, so can you press pause, have a go, make sure you've answered the questions. Okay, and then we will go through it. Okay, now it would make sense that if we're doing graph work, we do need to understand coordinates, and in fact that will be our first subunit so that we can make sure that we can work with coordinates and not just plot them. Okay, but let's look to see that we remember where coordinates are and how they work. Okay, so for 3a, it says to write down the coordinates of the points A, B, C, D, and E. Okay, so let's get that ready. Not a bad idea if this was a question in an exam to get that ready for yourselves so that you do not forget that your coordinates should be in brackets, okay, separated with a comma. All right, so let's look at A. Let's find it first. That's here. Okay, remember it's along the corridor, so we're doing the x-axis and then the y-axis. So along the corridor and then up or down the stairs. So that's going to be 3 and then up to 2, so that would be 3, 2. All right, if we look at B, that's going to be 4. We're not going up at all, so that's 4, 0. If we look at C, we're now going to the left, so that's -3, 1. Okay, for D, we're going left and then down, so that's -4, 3. And finally for E, we aren't going across from the origin, so that is a 0. But we are moving down to -2, so that is 0, -2. Okay, so hopefully we've remembered that. Well done. Right, and for part B, it's asking us which points have these coordinates. So let's write them down ahead of time so that we've got them, and then we'll look to see what points. Okay, so 2, -3, we're going across 2 and down 3. That is H. 5, 3, we're going across 5 and up 3, that's F. And -4, 5, we're going left -4, and then, sorry, where are we? -4, 5, and then up 5, which is G. Okay, so that was H, F, and G. So well done, those of you who got that. Good work. Okay, if you've gotten that, you're confident with coordinates. If you struggled with that, you now need to remember that we're going along the corridor and then up or down the stairs. Positive is to the right of the origin, negative is to the left of the origin if we're looking at the x-axis, and then positive would be above the origin or below the origin for negative if we're looking at the y-axis. Okay, so this one I'm going to make full screen for you. Press pause and give it a go. You will need square paper for this, please, okay, so that you can create your graph. Okay, well done. Let's take a look. Now, they've been quite nice in this question in that they've given us a starting point for our axes and how we create them. Okay, sometimes they won't provide you with that, so you have to decide what's appropriate in terms of a scale. Okay, and that is a skill you need to develop through practice, and that's one of the reasons why we are choosing this unit first. Okay. But for this question, they've given us a table which represents the cost of potatoes depending on the number of kilograms. Okay, and for part A, they want us to draw a graph for the data. They've given us the x-axis, saying it should go from 0 to 6, and they told us that the y-axis should go from 0 to 500. They've also given us a hint by telling us that we should separate out the y-axis in 100 increments and the x-axis in increments of 1. Okay, so let's create a graph now. Now they've used 5 squares on theirs to represent 100, so let's do the same thing on here. Okay, and they've used 5 squares to represent 1 on the x-axis. All right, so we have costs. You should always make sure that you are labeling based on what they've told you. Okay, and then here we have the number of kilograms. Okay, 0, and we could write 0 twice, but I choose to write it once if they're both 0. Okay, and here we go. So 5 squares is 1. Another 5 squares is 2, and then we would have continued this. 3, 4, 5, and 6. Sometimes that happens. Just add a little bit more, not the end of the world. Okay, 6. Yep. And then this one's supposed to go up to 500, so 100, 200, 300, 400, and 500. Okay, I have a feel for how much space I need. Notice I am actually using virtually all of this graph space. And you want to be doing that in exams. You don't want to make little tiny graphs way down in the corner of the graph paper they've given you, or in this case, the square paper, okay? You do need to make sure that you're using most of the area given to you. At least 50%, so at least half of the area, in order to make sure that you definitely get full marks. That's also important in science, okay? Right, so we've got cost and we've got the number of kilograms. Right, so let's take a look at the data that they gave us. They've told us that for 1 kilogram, we have 80 pence, okay? Well, if that's 100, then each of these are worth 20, because 100 divided by 5 is 20. So we have 20, 40, 60, 80. So I'm here. Okay. Then it says for 2, it's 160. So 2, we go up to 160. Then it says for 3, it's 240. We seem to be adding on 80 each time. Okay, so that should make your life a bit easier because 80 is worth 4 squares. So 1, 2, 3, 4 above. Okay, so that's easier to find. And 320 is another 80 up. So let's do that. 1, 2, 3, 4. Okay, that's 320. And then 400 is another 80 up. So we have 1, 2, 3. Sorry, don't even do that. Go up to here and let's do another 80 up. 1, 2, 3, 4. There we go. Much faster. All right. Right. Then we can connect. Okay. Now the cost of 0 kilograms is going to be 0. So in this case, I can go through the origin as well and connect it there. Okay. Right, it then says for part B to work out the cost of 3.5 kilograms of potatoes. So let's look at part B. So 3.5 kilograms of potatoes is Okay, and we're going to work that out. Now, the way you need to do this is to draw up from 3.5 kilograms, which is halfway here, okay? And then you go to your line, and you need to show this in an exam. You can't just use your finger. You actually have to show what you're doing, okay? And then once you've done that, you can go across. Now, they will always accept a range of possible values because everybody's lines are going to just be slightly different, slightly more crooked than another one. Okay, but I am at 280. So 280 pence. Okay, and then for part C, they've said, how much do 6 kilograms of potatoes cost? Okay, so now we're looking at 6 kilograms of potatoes. Now I know that this is a linear relationship, so I know that each extra kilogram costs a certain amount. In fact, each kilogram seems to cost 80. So I can extend this, and it's still valid because it is a direct relationship. If it wasn't, this prediction would not be allowed, okay? But in this case, I can tell that actually 6 kilograms, okay, and again, I would be showing this, use blue for this one. Yeah, and as expected, that is another 80. Okay, so 6 kilograms is 480 pence. All right, now we could have done that just by adding on 80, and that would have been acceptable. But it is nice if you have a graph to actually use the graph. Try not to do that because that just looks a little bit unfortunate. Okay, right, well done. Okay, so let's move on to another graphing one. I'm going to make that full screen. You're going to pause, you're going to have a go, and then we'll do that together. Okay. So this one is a pretty important one because it's looking at the conversion between miles and kilometers, and that does come up regularly. And we should remember, without having to look it up, that 5 miles is the same as 8 kilometers. That's an important conversion. I could also say that 1 mile is 1.6 kilometers for ease, okay? But this one says to copy and complete the table of values. Well, we can do this because we know how to convert miles into kilometers. All right, I'm going to show you how to come up with that conversion if you forget. Okay, so 5 miles equals 8 kilometers. Yes? And we're going from miles to kilometers in the table. I'm going to be multiplying. I'm getting to a larger number. It would be easier, though, if I knew what 1 mile was in kilometers. And in order to turn a 5 into a 1, I'm dividing by 5. I have to do the same with the 8. Now, if we use a calculator, 8 divided by 5 is 1.6 kilometers. But I would suggest strongly that you actually memorize this conversion and that you learn that 1 mile is equal to 1.6 kilometers. The reason that's useful is now I know if I ever want to go from miles to kilometers, then I can multiply by 1.6. And if I ever want to go from kilometers back to miles, where we're getting to a smaller value, then I can divide by 1.6 directly. So this is a much more useful conversion than the original one given to you. So I would definitely suggest you create a little revision card so that you can remember this forever. Okay, because that will be useful in your exams. Okay, now having said that, for our table we are going to be multiplying by 1.6, or we could think of it as the relationship in terms of how many sets of 5 and therefore how many sets of 8. Okay, so let's draw our table. Okay, so we had number of miles, and we had number of kilometers. Okay, and we have 5 different ones to do, so let's take a look at those. Okay, so we have 0, 5, 20, 50, and 100. Okay, now we could be multiplying by 1.6, easier with a calculator, or I could think about the fact that 0 is 0. We know that 5 is 8. Well, how many 5s are in 20? There's 4. So actually, if I am going from the 5 to the 20, I'm multiplying by 4, which means actually I can multiply that 8 by 4 as well, because there will be 4 sets of 8 kilometers, which is 32. Okay? Again, I could now look at, okay, well, how many sets of 5 are in 50? Well, that's times 10. So I can take that 8 and also multiply it by 10, which would give me 80. Okay? And the last one, and it's up to you, you could think about the fact that there's 20 5s, okay, and I multiply the 8 by 20, that's one way, or you could think about the fact that there are 5 20s and multiply the 32 by 5, whichever one's easier. I'm going to do the 5 times the 20, okay, and therefore 8 times the 20, which would be equal to 160, okay? So if you can see a relationship where you've got sets of amounts, then that can be a lot easier in a table than having to use a calculator, especially since, as we know, there's a non-calculator paper. So if we can see a pattern like this and we can use it to our advantage, then I do suggest it. Okay, now that we've got our table, we can do part B, which they've asked us to draw our graph. Okay, they again have given us a hint, and we know that we have to go all the way to 100 miles, okay, and we actually have to go all the way to 160 kilometers. I'm not going to fit that here if I'm using 5 squares, okay, so I'm going to move over to the back and draw a much larger version. Okay, and in fact, my square paper might have an issue with this. So I might do 2 squares instead of 5. I would suggest that for you guys as well, so that we're on the safe side and we can definitely fit it. Okay, so it should be fine. Let's put kilometers here. And miles here as they've instructed. 0, and I'm going to go every 2 because I want to make sure I definitely fit it. Okay, so don't think I'll fit 5. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, that's as far up as we went with the miles, but we know we have to go all the way up to 160. So that's 10, 20, 30. Notice how important it is for your increments to be equidistant, meaning equal distances apart from each other. Otherwise, you end up changing how much space is worth a certain value, and then you end up changing the values, okay, without meaning to. So it's really important that these are the same distance on your graph paper. Okay, so obviously they gave us 0, 0. Okay, And then the next one we had was 5, 8. So 5 up to 8. Now we can understand why it would have been much more useful to have 5 squares, but I can't fit it. So let's do our best. That's 8. Okay. 8 would be 4/5 of the way up. And then we had 20. Let me just double check. 20 was 32. So at 20, we're going up to 32, which will put a bit there. Okay. Then we had 50, which was going up to 80. Okay. So 50, luckily, we can do perfectly up to 80. Okay, and then 100 was at 160. Now, if you really struggle with that like I am at the moment, you're going to use a ruler to make sure you go up to the correct spot, which is there. Okay? Good. Right. And then you would connect. Okay, and I've done it quite well because we should have a perfectly straight line, which I do. Okay, because it's always the same number of miles in the same number of kilometers. Okay, so we would expect it to be a direct relationship and for it to be a straight line. Okay, and that's done. And then part C, that was part B. Part C says to use our graph to convert 70 miles into kilometers. So 70 miles is equal to, let's take a look. So we could approximate 112. Yeah. And let's actually just check that with our calculator because we know that our multiplier is, so let's check, 70 times 1.6 is equal to, how close were we? Oh, look, 112, perfect. Okay, and obviously the more little squares you had in between, the more accurate your results would be when you did that process. Okay, luckily we were fine with the 2 squares. That is all I could fit in. If this was an exam, they would give you the correct increments or number of squares to make it a little bit easier for you. Okay, but well done on that. Proud of you. Right, can you now press pause and try question 6, which is your algebraic fluency. Okay, so question 6 is to do with substitution. Okay, and question 7 is simple solving. So let's try both of them, press pause, and then we will go through the answers together. Okay, well done. Let's look at question 6. Okay, so question 6 is telling us that x is equal to 3, and they want us to find each of these values when x is equal to 3. Well, for the first one, negative x will be negative 3, okay, because we're substituting in the 3. For part B, 2x would be equal to 2 times 3. Please notice I'm using a bracket, because if that was negative, that would be particularly useful. 2 bracket 3 means 2 times 3, and that gives me 6. Part C, we have 3x plus 1. So that's 3 times 3 plus the 1. 3 times 3 we do first. Think about your order of operations. That's 9 plus 1, which is equal to 10. Final answer. Part D, we have 4x minus 2. Okay, that is equal to 4 times the 3, take away the 2 when we substitute. 4 times 3 is 12, take away 2, which is also 10. Okay, so that's question 6 done. Well done, guys, if you got that. Question 7, we are looking at solving. Okay, so remember, there were 2 rules that were really important for solving. The first one is to do the opposite. And the second one is to do the same to both sides. So whatever you do on the left, you have to make sure you do on the right. And remember, when you're solving, you're trying to get the variable, in this case the x, by itself, okay? So that's really important that you're isolating the x in this case. So let's look at part A. We have 3x equals 6. Well, 3x means 3 times x. The opposite of that is to divide. We should show this as a fraction. Divide by 3, divide by 3, and do the same to both sides. So if I'm dividing this by 3 to get x by itself, I need to also divide the right-hand side by 3. Those cancel out, and that leaves me with x is equal to 6 divided by 3, which is 2. Okay, and similarly for part B, we have 5x equals 30. So do the opposite of multiplication, which is to divide by 5, both sides. Okay, that's our second rule, remember. That cancels out, and we are left with x is equal to 30 divided by 5, which is 6. Okay, so well done, guys, if you got those. Right, we have one more fluency question to complete before this lesson is done. Okay, I don't think I need to make that full screen for you. You can see that, so please can you press pause. All right. And make sure you follow those steps and then press play when you're ready to go through your answer. Make sure you're on square paper for this one. Okay. All right, well done. Right, so let's take a look. They've said to draw a coordinate grid from -5 to 5 on both axes. That means that this is one with 4 quadrants. Okay, so let's get that done. So that you can see better, I'm probably going to double up my squares for you, okay? These ones are quite small. All right, so origin 0, and I'm going to double the squares, so 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. Okay, they did say from 5 to -5, so that's the y-axis done. Need to do the same for the x. Okay. All right, so we've got that sorted. Well done. And make sure you label that as the x-axis before we continue. Now notice I wasn't paranoid about, you know, how long this bit was, as long as I did label from -5 to 5 on both axes, leaving a little bit of extra space over here and here. It doesn't actually matter, okay? So we do waste a lot of time trying to make it perfectly going to 5 here and here, and actually you don't need to worry so much about that. As long as you start at the origin and you move out, it's fine. Right, so that's part A done. Part B says to plot the points A, which is 2, 3, B, which is 5, 3, and C, which is 4, 1. So let's do those one at a time. Let's start with A. So 2 and up to 3. Okay, and then B is 5 and up to 3. And C is 4 and up to 1. Okay, it then says... so that was part B done. It then says to mark the position of D on the graph to make it a parallelogram. Well, we can look at this visually. Okay, so if we look at B, it's 1, 2, 3, 4, 5, 6 away from A. So at C, since it has to be parallel, it's going to go horizontally, but it has to go the exact same number of squares because in a parallelogram, these two sides should be the same length, okay? So that's 1, 2, 3, 4, 5, 6. So that means my point D would be there, okay? It has asked us to mark the position and then to write down the coordinates of D. So for our last part, part D, we would need to write down the coordinates, which would be 1, 1. Okay, and that is D. Right. I think you've done very well with the fluency questions, okay? Please rewatch sections that you need to review again. You really need to make sure that this is solid before we move into the rest of the unit. Obviously, we'll do a little bit of coordinate work very soon, okay? And that will also be background for the remaining graph work, okay? All right, but well done, proud of you, and excellent work. Looking forward to the next video.